For my first factor, I'll be doing stirring that increases the rate of the solution. Why does stirring increase the dissolution? Because, well, the solute, when it's not stirred, it just sits there, right here. So when I pour this chocolate milk, it's just gonna sit there, and the solute is just gonna be right here. But when you mix it, it mixes with all the other particles within. So for this, I'll be using chocolate milk and leche. So I won't pour a lot, so you can see. So right here, this is the solute. Well, this is all right here. It's not mixed with like the particles within the milk. It's just right here, and it dissolves slowly. But when I stir, it increases the rate of the dissolution. So it starts to dissolve faster than it is because you're mixing all the other particles with the chocolate milk. What's the milk particles? Yeah. So you get chocolate milk. So yeah, so when you're stirring, it basically just increases the dissolving rate. So yeah, because well, you're just mixing all the other particles with each other. So yeah, just that's good. Next, I'll be doing the temperature increases the dissolving rate. Now, I'll be using cold water and hot water. Right now this is but and I'll be using this sugar. So I'm not gonna mix anything, but for this, it just sees how temperature can affect the dissolving rate. And I'm just gonna show it up close like this, by the way. So pour a lot right here, and then this is warm water. So on my left, warm water. Then right here, it's gonna pour into the cold water, and we're just gonna see difference in a few. And as you can see, the cold water, I spilled it. The cold water in the bottom right here, bring it up right here, it's starting to kind of fade away, dissolve, while the warm water, it starts to, it's barely dissolving right now, but I put the same amount and everything, but it's still there, as you can see. So but for some cases it could just be the amount of water you put in there, but I just don't think that. I think temperature does affect the dissolving rate, and I think that cold water affects it the most. So yeah, it's not even stirring, it's dissolving, but as it dissolves slowly, but it dissolves quicker, so temperature does increase the rate of dissolving. So get that out of the way. For next one, I'll be doing surface area or particle size decreases the dissolving rate. Now, hold up. Alright, so I have ice, full block ice, then I have crushed ice. So surface rate is just basically, because the outer part of the ice is gonna go away, but we're just seeing that which one goes away faster, and obviously ice crush is gonna dissolve faster because when you put it's already crushed, and that means it's almost to the center. For example, right here, this ice cube, you can see that it's fully blocked and everything, But with it, oh, I dropped it. But like Morin, it's more clear, or not more clear, but it's harder. It's hard to get in. So when you put water with it, it's gonna dissolve. But with crushed ice, since it's already crushed and almost to its center, it's all it's obviously gonna go away quicker because, well, so it's the surface. So we're gonna put water in there real quick. And when the ice breaks, it cuts up into different pieces. So if it has one ice cube, it's gonna be cut in half, then cut in this and that, and it just breaks down until it's gone. So we're gonna start with the crushed ice, and as you can see, more right here. There's hardly any ice cubes in there. There is one here. I'll just zoom it in right there. It's going away. It's almost gone. It's dissolved. Right here we have a full ice cube, hard solid. And so I'm gonna pour this in here. But look, it's still in there. So yeah, ice is still in there and everything. But with crushed ice, it kind of increases the solving rate. And it did increase the solving rate here because, as you can see, it's starting to dissolve. But since the ice cubes are bigger chunkers, it's going to take a longer time to dissolve. So we got those out of the way. Now, we're going to do temperature. Does temperature increase the gas solute? Or, yeah, does higher temperatures of the solute makes the gas more soluble? And so I know I have warm soda, and I hope it's warm, because if it's not warm I'm gonna cry. And I got a cold soda. So I don't know if you heard that, but it was kind of a pop. You can hear the acids here right there when I move it around, and that's because the cold water it doesn't really the cold water, it kind of doesn't. Alright, no problem. Okay, like for example, for this, it dissolved quicker, so the gas, it's not very poppy. You know, it decreased the gas. With warm, it's louder. And it's, you know, it didn't increase, it actually made it more, it made the gas stronger, and it made it, you know, pressured. So it pressured up, so the gas is right here, and it caught up all the way up to here until when you pop it, all the gas explodes and everything. Well, that's because of the warmer temperature, and it doesn't make it, you know, just to kind of dissolve quicker. So yeah, higher temperature does make it more solute. And the dissolving doesn't increase, it actually goes down. Cold water, quicker. Warm water, not quicker. Warm water, it's warm Coke makes it, you know, warmer, while this makes it more poppy, gassy. So yeah, that's my 4 factors. Stirring increases, surface area, temperature, and higher temperature. So yeah. Thank you.